In this question, two ships A and B's position vector after time t hours are given. In the part A, we have to find the bearing on which ship A is sailing. So let's revise the concept. So here we have the x and y coordinate system. So imagine, let's say the ship is at point B. A vector stands for the initial position vector. So that is its initial location. And let's say the ship is moving in this direction with a speed of B. B vector is the velocity vector here. In case B vector is Pi plus Qj, P stands for the x component of velocity. Q will mean the y component of the velocity. So the angle theta is found using the tan inverse of Q upon P. Now in the part A, we have to find the bearing on which ship A is sailing. So step one is to identify the velocity vector from the given equation. Let us see the equation. RA is 1 plus 2ti plus 3 minus 3tj. Now remember the basic equation R is written like A vector plus T times B vector. So we have to make sure that our expression is in this form. So R vector can be written as, if I expand the bracket, we'll get I plus 2Ti plus 3J minus 3Tj. And then the I and 3J, we will club them in one. So we will write I plus 3J. I will take t as common from the remaining terms. So we'll get 2I minus 3t. So now we can compare the given equation with the standard equation, which is A plus TB. Hence, we can say that the initial position vector for ship A is I plus 3j. And the velocity vector for ship A is 2 minus 3. Now let's try to figure out the bearing on which ship A is sailing. So if we draw the axis, and let's try to draw an arrow denoting the velocity vector. So B vector is 2 and minus 3, which means 2 in the x-axis and negative 3 in the y-axis. So let's draw that. So the ship is moving with a speed of 2 along the x-axis and with a speed of negative 3. Negative, that's why we are going in the negative y direction. And let us connect to get the original velocity vector. This is the v vector. Now, since we are supposed to find the bearing, and what does bearing stand for? Bearing implies the angle at which the velocity vector is making with the north. So on the axis on the right, if I denote the north in the positive y direction, so the angle which we have to figure out is this angle. Let's say this angle is theta, which is our bearing. Now we can see the theta is actually 90 degrees plus a small little angle here. Let's say that angle is alpha. So theta will be 90 plus alpha. And how do we find alpha? We use the same trick of tan. So in this right angle triangle, if we do, let's say tan alpha, that will be opposite upon adjacent. So 3 upon 2. And on simplifying this, alpha will come out as tan inverse of 3 by 2, which we will get as 56.3 degrees. Now the theta angle is 90 plus alpha. So let's write down the final answer. Bearing will be 90 plus the angle which we have found. 90 plus 56.3, which is equal to 146.3 degrees. And that is the answer for part A. In part B, we have to find the value of a time when the ship B is directly south of ship A. Let us draw the same coordinate system to understand. So for part B, if we draw the x and y axis, according to this part, we have ship B directly south of ship A. So let's draw that figure. Let's say a ship A is somewhere over here, and according to the part B, ship B is directly south of it. So we go a little down. Let's say the ship B is over here. Now, watch, A and B are basically, if you connect A and B, that is a line parallel to the y-axis. And whenever a line is parallel to the y-axis, x coordinate for every point on that line is constant. So let us write it down. The x coordinate for point A will be equal to the x coordinate for point B. And let's figure out the A and B's x coordinate. So we go back to the position vector equations. RA 1 plus 2t is the x coordinate for ship A, and minus 2 plus 4t is the x coordinate for ship B. So let's equate. 1 plus 2t is the x coordinate for A, and for B, The x coordinate is minus 2 plus 40. And let's simplify this. We'll get 2t equals to 3. This implies t is equal to 3 by 2, which is equal to 1.5. Hence, the time is 1.5 hours. And that is the answer for part B. In part C, we have to find the value of a time when ship B is directly southeast of ship A. So let us try to draw a similar figure, part C. Step 1 is to draw the coordinate system x and y. According to the question, part C, we have to find the time when the ship B is directly southeast of ship A. So like in the previous question, we assume, let's say A is over here, B is directly southeast. So that means B should be in this particular position. Now, the keyword here to note is in part C, they had given directly southeast, which means the angle in this particular case will be 45 degrees. So which angle I'm talking about? So the angle, this particular angle is 45 degrees. This is what we mean by directly southeast. And whenever the angle is 45 degrees, we know the x component and y components are equal. Tan 45 is 1, and that's why we can write AC will be equal to BC. AC is the x component of AB, and BC is the y component of AB. How do we figure out AB? So the vector AB is represented by B minus A, where B stands for the position vector of point B. Let's write that as RB. And A vector is the position vector of ship A after time T. Back to the question, we had been given the position vectors of ship A and B after time T. So to denote that in the diagram, if we connect the origin with point A, that will be our RA vector. And if we connect the origin with B, that is the RB vector. And if we do the subtraction RB minus RA, that will give us AB vector. So let's subtract the RB and RA. Let's go back to the question to check what RB was. Let us copy this entire equation so that it is easier for us to solve. Let us write RB and RA in the column vector notation. So we'll get minus 2 plus 40 and minus 4 plus t. Minus RA will be written as 1 plus 2t as the x component and 3 minus 3t as the y component. And let's simplify this. In the x component, we'll get minus 2 plus 4t minus 1 minus 2t. And the y component, we'll get minus 4 plus t minus 3 plus 3t. And let's simplify this. In the x component, we'll get minus 3 plus 2t. And in the y component, we'll get minus 7 plus 4t. Now we'll take the help of the angle 45 degrees. Since we saw whenever we have angle of 45 degrees, the x and y components are supposed to be equal. AC and BC are equal. So let's write that down. AC represents the x component of AB. AC is towards the positive x-axis. So we will write AC as it is, minus 3 plus 2t. Let's write it down. But the important point to note here is the y component, which we have found minus 7 plus 4t. That is from C to B, which means it is going in the negative y direction. So to identify BC, we'll have to put a minus sign to express the fact that CB is going towards the negative y-axis. So we'll get minus 7 plus 4t. Simplifying this, we'll get 7 minus 40. And now we use the concept that x and y components are equal. So we equate minus 3 plus 2t with 7 minus 4t. Let's simplify this expression. We'll get 6t equals to 10. T is equal to 10 upon 6, which is 5 by 3, which can be written as 1.66 hours. And that's the answer for part C.